Hello students, before we get into today's class, I wish to recall what we learnt in yesterday's class. We started a new concept, Venn diagram. Venn diagram is a diagrammatic representation of various sets and the various operations on sets. As we discussed yesterday, the universal set is expressed using a rectangle and all its subsets are represented using circles. And we saw three operations on sets called union of two sets, intersection of two sets and difference of two sets. Union of sets is nothing but it involves all the elements of both the sets. Whichever two sets we are going to find the union, then it will contain all the elements of A and B, which that is A union B is equal to set of all x such that x is equals to A or x equals to x belongs to B. That particular element, either it should be available in A or in B, and we have seen how we can express through Venn diagram. Then we have seen intersection of two sets. Intersection of two sets, A intersection B is equals to the set of all x such that x belongs to A and x belongs to B. In union, it is suffice if it is available in any one of the sets, but in intersection, it is compulsorily available in both the sets. Then only it will exist in intersection. And we have seen how we can express the intersection of two sets using Venn diagram. Then at last we saw difference of two sets. A difference of two sets A and B in this order. When we talk about difference of two sets, the order in which we are going to find the difference plays a vital role. If we are going to find A minus B, then which is equal to set of all x such that x belongs to A and x does not belongs to B. I told you first to find the common elements of both the sets, and then the elements which is remaining in the first set will be the answer for A minus B. If you are going to find B minus A, then the elements remaining in the set B will be B minus A. That's why it is given set of all x such that x belongs to A and x does not belongs to B. If it is going to be B minus A, then set of all x such that x belongs to B and x does not belongs to A. And we have even seen how we can express using Venn diagram. Then at last we have discussed a few properties. Commutative property, which holds good for union and intersection. Associative property also holds good for union and intersection. Next is identity. Here null set is the identity. If you find union of a set with null set, you will get the same set as your answer. If you find the intersection with the null set, obviously you will get null set as your answer. Then idempotent, which is new to you. Idempotent is finding the operation with the same set. A union A. A union A is nothing but the same set A. If we are going to find the intersection also, we will be getting the same set. Then law of union. If you find the union of a set with the universal set, and obviously you will get the entire elements in the universal set as your answer. If you are going to find the intersection of a set with the universal set, you will get the set as your answer. Then the last property which we learnt is distributive. Distributive of intersection over union. For distributive property, we need two operations, right? So the same way here, intersection and union. A intersection B union C is nothing but A intersection B union A intersection C. Now we are going to prove this distributive law through Venn diagram. Let us see how we can prove this. So first we will take the left hand side. Left hand side is A intersection B union C. We cannot prove it directly. We will go step by step. First draw the diagram for B union C. Till yesterday we have seen for two sets, right? Now we are going to extend it for three sets. So you have to draw three circles, right? Unless and until it is given in the question that the sets are disjoint, always we will go for the overlapping of sets. Yeah, either even if it is disjoint or a subset of another set, it will be mentioned clearly in the question, or else you can go for the overlapping of sets. Now I am going to take this circle as A, this as B and this as C. Now I am going to find what is B union C. Always we will give preference to the things which is inside braces, right? So first let us find what is B union C. B union C means under union operation we will get all the elements in B as well as the elements in C. So here this circle is fully B and this circle is fully C. Therefore this represents B union C, right? Next we are going to find A intersection B union C. So the same way, draw 3 circles. This is A, B, C. Now we are going to find A intersection B union C. In the sense, now we are going to compare B union C with A and we are going to check out which is common in both the sets. Now look at this diagram. This is your A and this is your B union C. Now which is the common in both A and B union C? This region. This region, right? This region is available in both A as well as B union C. Therefore, this region alone should be shaded for A intersection B union C, right? This represents A intersection B union C. Intersection means common elements. Now, we are going to check out which is common in both B union C as well as A. B union C we have done already. Now we are going to find which is common in both A and B union C. A is this full circle, B union C is these two entire circles. So if we analyze these two, this is the only region which is available in both A and B union C. Therefore, this region is A intersection B union C, right? Now let us see we have found out what is A intersection B union C. Now we will move on to the right hand side and we will check out whether are we getting the same answer. Now RHS. First we will find out what is A intersection B. So for A intersection B we don't need 3 sets, but still since we are dealing with 3 sets, draw 3 circles A, B, C, and now we are going to find out what is A intersection B. So for A intersection B we need to compare only A and B. This is your A and this is your B. Which is common in both A and B? This region, right? So this is your A intersection B. Next we need to find what is your A intersection C. Again draw 3 circles A, B, C. Now we are going to find what is A intersection C. Now compare the circle A with C. This is your A and this is your C. So which is common in A and C? This region. This is A intersection C. Now we need to find A intersection B union A intersection C, right? So draw 3 circles. This is A, B, C. This is A intersection B, this is A intersection C, and we need to find the union of these two. Union means we have to shade this region as well as this region. So first shade this region where we have shaded in A intersection B, this, and where we have shaded in A intersection C, this region, and already this shaded, and we know in a set repetition is not allowed. So this is A intersection B union A intersection C. And see the right hand side arrived, what we arrived is same as the left hand side what we arrived. Hence RHS is same as LHS. Thus the distributive law is verified or proved using Venn diagram. Therefore A intersection B union C is equals to A intersection B union A intersection C. This how only you have to prove using Venn diagram. Right? Before we move on to the exercise, I wish to tell you or discuss one important note. This will be useful while we are moving on to the next topics. The sets A minus B, B minus A and A intersection B are mutually disjoint sets. Mutually disjoint sets. Disjoint means the sets which doesn't have any element in intersection, which doesn't have any element in common, right? A minus B means which region we will shade? The remaining region in A, which is not common in A and B, the remaining region in A. When it comes to B minus A, we will shade the remaining region in B which is not common in A. And this middle region is A intersection B. Obviously, A minus B, B minus A intersection B, all the three sets are mutually disjoint sets. If we find the intersection of any of these two sets, the answer will be null set, right? Now let us move on to exercise 1.4. So let us see exercise 1.4. First 4 problems, I have given it as homework. Hope you have done. Now we will see the fifth subdivision in the fourth problem. It is union of 3 sets, A union, B union, C. How will you find A union, B union, C? Directly you can find, because union is just the combination of all the elements which is available in the set A, B and C. You can start writing the elements from set A, but you should not repeat the elements. So first we will write the elements in set A, 1, 2, 3, 4. Then write the elements in set B, 3, 4 we have written already. So you can write 5, 6. Then C is asked, 5, 6 already written. So it is 7 and 8. So this is A union, B union, C. Or else you can go by solving using associative law. First you can find what is A union B. Then you can find union with C. Like that also you can solve. Now see the sixth question. They have given 4 sets A, B, C, D, and first question they asked you to find the intersection A intersection B. How will you find A intersection B? A intersection B is the elements which is common in both A and B. Which are the elements common in A and B? See, 3 and 5 are not there in set B, whereas 7, 9 and 11 are there in set B. So A intersection B will be 7, 9, 11. Now how will you find the intersection of 3 sets now? Intersection of 3 sets means the element which is available in all the 3 sets only will come under this A intersection C intersection D. So which means you should check the set A, set C and set D and find which element is available in all the 3 sets. If we check out 3 is not available in C and D, 5 is not available in C and D, 7 is not available in C and D, 9 is not available in C and D, 11 is available in C but not in D. When we find the intersection of 3 sets, it should be available in all the 3 sets, but it is not there. Therefore, the answer will be null set. Or else, you can solve this problem using associative property as I told for union. Let us see how we can find. We have learnt associative property is true for both union and intersection, right? So I can find A intersection C intersection D as A intersection C intersection D. So first find what is A intersection C. So first find what is A intersection C. What is A intersection C? If we find the common elements of A and C, it is only 11. So A intersection C is 11. Now we need to find A intersection C intersection D. A intersection C is singleton set with 11 intersection D. What are the elements in D? 15 and 17. Now which is common in these two sets? None of the elements. So the answer is null set. Hope you understood now. If you were able to solve the problem directly, solve it directly, or else you can use associative property and you can solve. The same way you can solve the problem based on union also. Right? Now let us see 8th subdivision in the same 6th question, which is A intersection B union D, which is nothing but the distributive property, right? So how you will find, as I told you, always we will give preference to the things which is inside the braces. So first find what is B union D. B union D means always solve the problem step by step so that you won't make mistake and even the things will be clear for the examiner or the evaluator. Don't answer it in a single step, right? So first find B union D. B union D means you have to find the union of the set B and D. So what are all the elements available? 7, 9, 11, 13, 15 and 17. Now we need to find A intersection B union D, which means for the set A with the set B union D, you need to find the intersection. Where is A? A is here. If you want, you can write in the below this B union D also, so that you won't make any mistake. So I am going to write here. The set A has 3, 5, 7, 9 and 11. Now see which are all the elements are common here. 7, 9, 11, right? So A intersection B union D will have 7, 9 and 11, right? Hope you understood. Similarly, you can solve the remaining subdivisions. If you check out the 7th question in the textbook, the question is given in the set builder form. So you should know how to convert the set builder notation into the roster form. So once you converted it into the roster form, the problem will become easier. You can directly find the A intersection B, A intersection C, whatever is given in the question. So in the 7th question, set A is set of all x such that x is a natural number. So A will have what are all the elements? Natural number starts from 1. So it will have elements starts from 1 is a natural number. They didn't give the end point. So 1, 2, 3, etc. All the number will be available in set A. Then set B is set of all x such that x is an even natural number. So it will have 2, 4, 6, etc. Which means set A, set B all are infinite sets. Then set C is the set of all x such that x is an odd natural number. It will consist of odd numbers. Again, it's an infinite set. Set D is a prime number. The set of all x such that x is a prime number. Again, it's an infinite set. So all the sets given in problem 7 are infinite sets. For the infinite sets, they asked you to find the intersection. Again, the answer will be in the infinite set only. So for A intersection B, what will be your answers? You will be listing out a few elements and then you place etc. so that it will become an infinite set, right? 7th question is actually an interesting question. See, set A has set of all natural numbers. The question is given in set builder form. So it will have elements like 1, 2, 3, etc. It's an infinite set as I told you. And set B is even natural numbers. So it is again an infinite set. Set C is odd natural number. Again it's an infinite set. D is set of all prime numbers. When you are listing out prime number, be careful. One is neither a prime nor a composite. It's a unique number. So you should not list out. So you should start from number 2, 2, 3, 5, 7, etc. Now what is A intersection B? Listen carefully. A is a set of all natural numbers. B is set of all even natural numbers. So when you find the intersection, what will be there in A intersection B? A intersection B we will have, because in set A all the numbers are available. In set B only even numbers. So when you find the intersection, obviously you will get the even numbers. So 2, 4, 6, etc. which is nothing but set B, right? So what will happen if you find the intersection with A and C? Again, the set A has all the numbers, whereas set C has only odd numbers. So when you find the intersection, you will get the odd numbers. So 1, 3, 5, etc. which is nothing but set C. Now what is A intersection D? Again, set A has all the elements, set D has only the prime number. So when you find the intersection, you will get only the prime numbers, which is nothing but set D. Now listen, what will happen if you find the intersection of B and C? B is set of all even numbers, C is set of all odd numbers. So what will be the intersection here? Null set. We don't have any intersection, therefore the answer is null set, or you can denote like this, right? So it's a null set. Then what is B intersection D? What is set B actually? Set B is set of all even numbers and set D is set of all prime numbers. So what will be the intersection? Only 2, right? 2 is the only even prime number. So you will get answer as singleton 2, right? Now what is C intersection D? C is set of all odd numbers and D is set of all prime numbers. So what will be C intersection D? When we find C intersection D, here we won't get answer as any one of the given set, right? Leaving 2, we will get the remaining odd numbers. So C intersection D will be set of all x such that x is the odd prime number. X is the odd prime number. Hope you understood. This is not any one of the set which is given in the question. So you should write it like in set builder form, or if you want to express it in roster form also, you can express the answer like 3, 5, 7, etc. Again, it's an infinite set, right? Remaining questions in the exercise are easy. I hope you can solve by yourself. 8th question, which of the following pairs of sets are disjoint? Disjoint means, as I told in the beginning of the class, where the intersection is empty. Check out whether the intersection of two sets are empty or not. If it is null set, then the two sets are said to be disjoint. 9th problem is finding the difference, and the 10th problem is based on the note which we saw in the before in the starting of the class. As I told you, A minus B, B minus A, and A intersection B, all the three are disjoint sets. So they have given you two sets and they asked you to find all the three. So you can very well come to a conclusion that all the three are disjoint. All the three answers will be completely different. 11th question is interesting. If R is the set of real numbers and Q is the set of rational numbers, what is R minus Q? See, R is set of real numbers, we know. Q is set of rational numbers, we know. They asked you to find what is R minus Q. What is R minus Q? How we will find the difference? We will leave the common elements and we will write the remaining elements of the first set. So real numbers is the entire set. In that we have rational numbers and irrational numbers. When we subtract R minus Q, leaving the rational numbers, what will be the remaining elements in R? Which is nothing but irrational numbers. So R minus Q will be T, the set of all irrational numbers. You can write the set of all x such that x belongs to R and x does not belongs to Q, which is set of all irrational numbers. And the last question is nothing but true or false. Hope you can do it. Now let us see the next small topic, complement of a set. Now let us see the next concept, complement of a set. What is meant by complement of a set? The elements of universal set. This concept is related to the universal set. The elements of U which are not the elements of A. For example, if you are going to find the complement of set A, we will check out, compare the set A with the universal set, and we will leave the common elements and we will write the remaining elements of universal set. When I am explaining itself, you can find the similarity between the complement and the difference of sets. While explaining difference of sets also, I told the same kind of explanation, right? What I told you, what you will do while finding the difference of two sets, if you are going to find the difference of two sets, say A and B, we will leave the common elements of A and B and we will write the remaining elements in set A, right? The same way in complement of a set, we are going to just find the difference but with the universal set. U minus A is going to be A complement, right? What is complement of a set? Complement of a set is nothing but the difference between universal set and the given set. U minus A is the A complement, right? It is denoted by like this, A dash. A dash is equal to the set of all x such that x belongs to U and x does not belongs to A. So which is nothing but U minus A. Let us solve an example. For example, the universal set has elements from 1 to 10 and the set A has elements 1 to 9. Then what will be A dash? A dash is the remaining elements of the universal sets leaving the elements of set A. So 1 is there, so you should write 2. 3 is there, so you should not write 4. 5 is there, so you should not write then 6. 7 is there, so 8. 9 is there, so 10. So this is A dash. Now let us check out what will happen if we find the complement for the complement of a set. In the sense A dash the whole dash. Now I am going to find the complement for this set. Complement means what? Now we will compare this set with the universal set. We will leave the common elements and we will write the remaining elements. So what will happen? I am going to compare A dash with U. So 2 is there, 1 is not there in A dash, so I am going to start with 1. 2 is here, 3 is not here, so I should write 3. 4 is here, 5 is not here, so you should write 5. 6 is here, 7 is not here, so I am going to write 7. 8 is here, 9 is not here, so I need to write 9. 10 is there. So if you check out, this is nothing but your set A. So the complement of the set is nothing but the same set. A dash, the whole dash is nothing but A. Right? Complement is denoted by dash and we will read it as A dash. A dash is nothing but the difference between the universal set and the set. And A dash, the whole dash is nothing but the same set itself. This complement of a set can be expressed or represented in Venn diagram like this. Because we know universal set is represented by the rectangle and the set A is represented by a circle, and when it is A complement, it is the remaining of A in the universal set. Remaining of A in the universal set. So the remaining region is shaded here. Yes, now let us see few properties of the complement as we have seen for union, intersection and difference. Now A union, A complement. The set A is there and its complement. If you find the union, what will happen? The entire universal set you will get, because in the complement of a set we are going to write the remaining elements of set A which is available in the universal set, right? So when you are going to find the union, you will get the entire universal set. On the other hand, if you find the intersection, there won't be any element in common because we are not going to write any of the element which is there in set A in its complement. So when you find the intersection, it will be truly null set. Then A union B the whole dash is nothing but A dash intersection B dash, and A intersection B the whole dash is nothing but A dash union B dash. These two laws are called De Morgan's law. You may come across in problem saying that instead of giving the question, they may say prove the De Morgan's law for the given question, which means you have to state this law and you have to verify for the given question. This can be verified using even Venn diagram. You can try. First, how we can prove this using Venn diagram? First, find what is A union B, represent it using Venn diagram, and then you find what is A union B the whole dash. Leave it aside. Then move on to the right hand side. Find what is A dash, find what is B dash, then find the intersection and check out whether both are same or not. And you can see here, when it is union on one side, it is intersection on the other side. When it is intersection on one side, union on the other side. So these two laws are called De Morgan's law. Then A dash the whole dash is A, just now we saw through an numerical example. Then null set. Null set complement will be nothing but the universal set. Universal set complement will be nothing but the null set. Yes, hope you understood. In today's class, we have started with the description of distributive law using Venn diagram, and then we have seen an important note, which is A minus B, B minus A and A intersection B all are mutually disjoint sets. Then we solved problems in exercise 1.4 and we have learnt what is meant by a complement of a set, right? So with this we will wind up today's class. Do these problems as homework, and as I mentioned earlier, every Saturday you will be writing a small test for 20 or 25 marks. It depends on the portion what we completed in that particular week. So as tomorrow is Saturday, you will be writing a test. I will post a question paper in the group by 10 or 10:30, and within an hour gap you should repost the answers in the group again, right? So do practice till the concept of complement of a set. So tomorrow you will be writing a test till complement of a set, starting from the definition of a set. All the best. Do well. Thank you, students.